Hello everyone. In this video, we'll be learning what is Snowflake, why companies are rapidly adopting it, and what's the problem that it actually solves. So let's rewind a little back into what was the scenario even before Snowflake has entered the data world. The data was being predominantly stored in databases and data warehouses. So for both database and data warehouses, the physical server, the database software is being installed. So whatever the data, it is getting stored in the disk space of the server. When we fire a query, it uses the CPU cores of the server for compute. So technically speaking, we could think that both database and data warehouse can be in the same server, right? But in the real life, this is not so, because data warehouse requires high compute because we are going to run complex queries. So if data warehouse queries uses a large amount of compute, then there would be only less compute left for database queries. So that's why we always prefer a separate server for both database as well as for data warehouse. And in database, the storage is in form of row base so that we can quickly update, insert, or delete the data. And it predominantly stores the current data and not much historical data. But data warehouse, it stores historical data with the data being only appended and not deleted or updated. And the storage is in the form of columnar so that aggregations can happen easily. So when we look, data warehouse has much more storage and compute compared to database because of much more data being stored and much more complex queries being written. But the one problem that the both database and data warehouse share in common is the tight coupling of storage and compute. Imagine the physical server has 4 TB of disk space, but the actual data that we store is around 2 TB, and there are 16 CPU cores. Now, 100 users are going to concurrently query the database. What happens? So, usually, the query, which takes only 2 minutes to give the results, it now starts to take a lot amount of time. Why? Because they all share the same compute. So suppose if the company wants to increase only the compute capacity, it's not possible for them in the traditional database or data warehouses because the storage and compute are tightly coupled. Despite the storage was only 50% used and still 50% is not yet used, they're even forced to buy a server that has storage and compute capacity. So these are highly expensive and it's difficult for the company to manage. And there would also be downtime while upgrading the compute capacity. And when we run a heavy query, it blocks other queries also. Simple queries they might be writing, but it may block even that because of the complex query that's being written and the shared compute that's being used. So, the one thing that we ought to understand here is only the compute cannot be increased. Both storage and compute has to be increased in any of the case in both traditional database and data warehouse system. This is where Snowflake comes to solve the problem. So Snowflake is called as a cloud data warehousing tool. Why? Because what the problem is the tight coupling of storage and compute. So this cloud storage, it resolves this problem because there's going to be separate machines for storage and separate machines for compute. And there is no coupling between both of them. They are independent. So one of the problem is completely solved. But how do they both communicate? So the compute wants to get data from the cloud storage and perform the processing and give us the results. So this communication happens via private networks. Then you may think, Why do we need Snowflake? If data is stored in the cloud and computation happens in other machine, then what is the purpose of Snowflake? So imagine you have 10 TB of data stored in the cloud storage, for example, Amazon S3, and you write a query, SQL query called select star from a particular table, uh, limit, etc. Will the S3 understand and give you the query result? No, because S3 just stores files. It does not know what tables, joins, SQL, etc. So that's where Snowflake comes in. So when you run a SQL query, the Snowflake understands the SQL and it picks up the fastest way to execute the query. It spins up the machines and it reads data from the storage, it processes results. So it automatically manages every scaling, performance, and infrastructure. So this is the reason why a lot of companies prefer Snowflake because of the less or no coupling between, there is actually no coupling between the storage and compute. And everything is automatically managed by Snowflake. So if the compute resources are much needed only for just 2 hours by the company, it just spins up the resources only for 2 hours and the remaining hours it just pulls it down. So this is what Snowflake is about. In further videos, we'll be learning more about Snowflake. I hope you find it interesting. Thanks for watching.